Hey guys, this video goes along with page 3 of your interactive notebook. It's about rounding and performing calculations with significant figures. So I'm going to start by giving you the rules for rounding. So when we're rounding with significant figures, we want to use the digit after the last significant figure for rounding. So we're going to look at a number, determine how many significant figures we want that number to have, and then the next number, which will be non-significant, that's what we're going to use for rounding. But make sure that whenever you're rounding for significant figures, you never drop places. You want to use placeholder zeros when necessary, but you don't want, for example, to round 387 to 4. That would be a truncation error is what we call that. So don't drop places, instead use placeholder zeros. So we're going to look to the left, and we're going to look at a few different examples of rounding with significant figures. So for A, B, and C here to start, for the first three, we're going to round all of these to two significant figures. So this first number that I have is 3591. So I'm going to count 2 significant figures, and then I'm going to use the next digit, which I've circled here, the 9, for rounding. Since the 9 is a 5 or higher, I know to round this previous digit up. So this 5 is going to round to a 6. But these two places, the tens and the ones in the tens place, I don't want to drop those. I want to put placeholder zeros in their place. So then this rounds to 3,600. That 5 becomes a 6, and then those two digits are replaced with zeros. If we look at B, we have another example. It's 1.237, so we're going to count our first two significant figures, 1, 2, and we use the next digit of 3 for rounding. Since the 3 is lower than 5, the 2 is going to round down or stay the same. Now this time we don't add any zeros to it, because since they would be final zeros after a decimal, they would be significant, and we don't want that. We only want two significant figures. So instead we're going to drop them. We don't need to use placeholder zeros this time because they come after the decimal. So instead, this becomes 1.2, the 2 rounds down. In C, we have another decimal, 0.00347. We're going to round to two significant figures. Remember that these first two zeros, these placeholder or leading zeros, don't count. So we start counting 1, 2. We'll use that next digit for rounding. It's a 7. That's 5 or higher. So this rounds to 0.035. In the second half, you can just see three more examples, but this time rounding to one significant figure. So we have 4,300. The first digit is a 4. The second one is a 3. That 3 tells us to round down, so it'll be 4,000. 8.731, here's our significant figure that we want. The 7 is 5 or higher, so we round up to 9. And then 0.0964. We're going to go all the way to the 9 for our significant figure. The next digit, though, is a 6. That's 5 or higher, so it tells us to round up. So this will end up being 0.1. Okay, so why do we actually want to round these numbers to a certain number of significant figures anyway? And the answer to that question comes whenever we calculate with significant figures. Remember that significant figures carry meaning about the precision of a number. So whenever we do calculations with measurements that we took in the lab, our answer to those calculations can never be more precise than the original measured values that go into them. So we're going to look at the rules here for calculating with significant figures, and there's going to be two different ones, one for adding and subtracting and one for multiplying and dividing. So we'll start with addition and subtraction. The rule says that when adding or subtracting, round your answer to the same number of decimal places as the number with the fewest decimal places. So on the left, we'll look at two examples for this. The first example here, 2.35 centimeters plus 1.5 centimeters. So we're going to add these numbers up together, type them into our calculator, and we get 3.85 centimeters. But since we're adding, we're going to have to round our answer to the number of decimal places that is the same as the lowest number of decimal places. So in this first value here, we have 2 places after the decimal, and in the second one, we only have 1. And since that 1 is a smaller number, we're going to round our answer to just 1 decimal place, and right now we have 2. So after this 8, we look at the 5. The 5 is 5 or greater, so it tells us to round up. So we'll round this to 3.9 centimeters. Notice that this time we're not necessarily counting significant figures. There's two significant figures in this number. The rule for addition and subtraction only applies to decimal places. Let's take another look at an example, number 2 here. This is finding the volume of an object using water displacement. So we did something like this in the lab. In this graduated cylinder, we have a marble, and there is an initial volume of 10.50 milliliters. That's just the volume of the water. And then a final volume that is the volume of the water plus the marble, and that's 12.50 milliliters. So we're going to use these two things to calculate the volume of just the marble by subtracting the initial from the final volume. So 12.500 milliliters minus 10.500 milliliters equals 2.00 milliliters. We're going to round that to the same number of decimal places as the measured value with the least number of decimal places. There's 2 here and 2 here. Those are the same, so we'll round our answer to 2.00 milliliters. So let's go back to the right and talk about multiplication and division. The rule is a little bit different for multiplying and dividing. Whenever we multiply or divide, we're going to round our answer to the same number of significant figures as the number with the fewest significant figures. So instead of decimal places this time, it'll be significant figures. So again, we'll look at 2 more examples on the left. Example number 3 says we have 2.00 centimeters times 6 centimeters. Of course, everybody knows that 2 times 6 is 12. However, when we look at our measured values, we have 3 significant figures here and only 1 significant figure here. So we have to round our answer to only 1 significant figure. So we hit our first significant figure here, the 1, and we're going to use the next digit, a 2, for rounding. And since that's 5 or less, we're going to round down. So this actually becomes just 10 centimeters squared. And that's to 1 significant figure. And I know that sounds silly, but again, remember that this is all about there being a measure of uncertainty within this value. We can't really precisely calculate this value because the measurement that went into it was imprecise. And so the number that we generate has to reflect that. So I know that it seems a little bit silly, right? 2 times 6 is 10, but for the sake of this class, it is. Now, if this was 2.00 centimeters times 6.00 centimeters, well, then it would be 12.0. And that, I know, makes a lot more sense. So really count those significant figures. Make sure that your answer is not more precise than your least precise measurement. So that's why we had to round here. One more example, example 4, we're going to calculate density of an object. It has a mass of 27.34 grams and a volume of 2.91 milliliters. Type that into our calculator, we get this big, long, ugly number, but we're going to round it. We have 4 significant figures here, 3 significant figures here, so we'll round to 3. It'll be 1, 2, 3. That next digit is a 5, which tells us to round up. So the 9 rounds up to a 0 and then rounds the 3 up to a 4, right? So it's 9.40 grams per milliliter. So then the last thing that you're going to do is glue your Apply Significant Figures and Calculations page into that left-hand margin, and you'll be all done with page 3 on rounding and calculating with significant figures.